Hello, 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 and welcome to the OpenTelemetry Deep Dive webinar for March. And yeah, I'm your host for today. I'm Adnan. I do developer relations here at Bindplane. And with me, I have Mike, our CEO, and Ryan, that's the head of product. So let me hand over to Mike first to do an intro, and then Ryan, and we can jump right in.
Yeah, thanks, Adnan. Thanks everyone for joining. I'm Mike Kelly, I'm the CEO founder of Bindplane. Been involved in OpenTelemetry for the past few years since we initially donated the log engine behind the OpenTelemetry Collector, and looking forward to talking about it.
Yeah, hey everyone, I'm Ryan. I lead product here at Bindplane. Thanks for joining today. I'll be kind of in the background answering any questions you guys have. So fire off your questions throughout in the Q&A, and I'll do my best to answer.
Sweet. Yeah, we can just jump right into the agenda for today. So we have a four-part workshop for today, more or less. We're going to do first and foremost, we're going to do an OpenTelemetry primer. So we'll talk about OpenTelemetry, what it is, why it's important, how to use it, and obviously how to run it in production. We'll also talk about the OpenTelemetry Collector more specifically. We'll go into deployment patterns for the collector, all of the components that go into the collector, the config, how to debug it, and then basically how to run it yourself. We'll also have two demos included for these two topics as well. But we'll also round everything out with talking about Bindplane as a control plane for collectors, and basically talking about telemetry pipelines and how Bindplane is an OpenTelemetry native telemetry pipeline. So you'll take away from the workshop today, specifically, you'll learn how to deploy OTel in production, and you'll also learn how to manage, deploy, and configure OTel collectors as well. So we have a bunch of cool topics for today, and we're going to kick it off by handing over to Mike first to talk a bit about OpenTelemetry and give us the introductory primer to what OpenTelemetry is.
Yeah, thanks. And we'll talk a little bit about these and won't spend too much time on it. I think a lot of folks on joining know about OpenTelemetry, but just as a recap, the project, this is a large project. It's the second largest project in the CNCF behind Kubernetes. And it spans a lot of ground. It's protocols, so it's very well-defined protocols and specification that define how to collect, process, and transmit telemetry data. Mostly metrics, traces, and logs, but it goes beyond that, and it's starting to expand. The next piece is the instrumentation. And this is, if you were early to OpenTelemetry, this is probably what you know it as. It's an SDK ecosystem. Use it to instrument your applications. You can collect traces. It supports a number of programming languages. It now supports auto instrumentation for a number of languages as well. And then the last component where we're going to spend most of the time today is the OpenTelemetry Collector. And this is vendor agnostic agent, supports collecting traces, metrics, logs, is deployed. But you can, this is become very popular in a way of replacing what you have as proprietary, but also other open source agents as a standardized way of collecting telemetry in general. The next thing we like to think about is why would you consider OpenTelemetry? And there are three primary reasons. One is you're standardizing. So, if you're using one, and this is really why the industry has gotten behind it, but standardizing and simplifying. So if you have a single set of open source tools for collecting and standardizing all of your data, makes it much easier on a number of levels. It makes it easier for your teams to understand how to configure, how to deploy, because you just have one agent and one SDK. It also standardizes the telemetry types, and it reduces the need to have multiple agents on a single instance, which as you expand out what you're using for analysis, whether it's security-based, observability-based, or even just compliance, storing, say, logs for long term, it's much easier if you're using one pipeline, one agent type to do that. The other goal is to be vendor neutral. And that means you don't need to use proprietary solutions. You can use a single vendor neutral solution for everything. But that doesn't work unless you have or really full industry adoption or near full industry adoption. And so that's the third key point is this is a project that has the backing of companies across the board, and nearly everyone either is supporting OpenTelemetry or is using it as the default option. It has really become, has grown quickly and is supported by the vast majority of observability vendors today. So we're going to talk a little bit about OpenTelemetry in production, but we're going to start with OpenTelemetry and the collector and some of the basics of it first. But this is really the goal, the end goal. I think most customers are looking for OpenTelemetry as a building block to creating a full data plane or telemetry plane. And that means it's a simple, single system to learn. But the building block of that is the OpenTelemetry Collector. Right? Once you have this in place and you have it throughout your infrastructure, you're dramatically improving the control you have of the data. You're not locked into a vendor. It's easy to reroute and add or remove observability front ends, whether it's for logs, metrics, traces. Once this is in place, you have far more control of telemetry within an environment. And so we'll talk about how to get there and start with the OpenTelemetry Collector, which is, like I said, the building block. And we look at the collector, there are a lot of components to it, but the key components to understand are receivers, processors, and exporters. Receivers let you collect metrics, traces, and logs. So you can think of this as you need to gather host metrics from a virtual machine or logs from a custom application, or you want to ingest syslog or say Apache or Aerospike. There are over 90, and it's probably even well beyond that at this point, what we call official receivers that are in the OpenTelemetry repository and supported by the OpenTelemetry project for all the common data sources. At the processor level, this is where you can do things like transformation. So you're able to batch data, filter data, sample data, redact. That's all done with processors within OpenTelemetry. And then finally, exporters let you send that process telemetry to one or more destinations. And again, there's a wide range of exporters and destinations supported, things like Google Cloud, Kafka, Cassandra, even the generic OTLP, so the OpenTelemetry protocol, is supported at each stage. But it's very likely that where you want to send this data, it's going to be available as an exporter. Usually the first place that you start when you're looking at OpenTelemetry is the distributions, and this can be a place people get blocked or confused starting out because there are a couple of official distributions. There are vendor distributions, and then you can build your own. Those are really the three key options you have. Among the official distributions, there's the Contrib distro. This has almost everything. So it includes the majority of the receivers, includes the majority of the processors and exporters that are considered at a stable point to be released. And if you use this, you're going to have something that will work with just about anything. The core distro is really the absolute minimum that's needed to be considered a collector. For most customers, that's not going to do what you need, and you need some additional functionality built on top of it. There are vendor distributions, so a lot of vendors have these. Splunk has one, AWS has one. We have a Bindplane distribution for OpenTelemetry. What we recommend when you're looking at these is make sure that it includes the components that you're going to need. So if you're thinking about, just showed you the receivers, processors, exporters, think about where your telemetry needs to go. And if you're using a vendor distribution, make sure that it's including those and it's not locked into a specific use case that won't support where you're headed. So we usually recommend a great place to start is with Contrib, which has, like I said, almost everything. You can then pare it down if you need to afterwards, but it's a good place to start. The Bindplane distro for OpenTelemetry, just highlighted here. Similar, we have what we consider all the key components designed in a very vendor neutral way. We want to support as many destinations as possible, include all the key processors and receivers, and some of our own components are included with that as well before they move upstream. That is also open source. The last option for building your own collector, this is something that you can do with the OpenTelemetry Collector builder. You really just have to consider that there's going to be maintenance associated with that that you'll need to take on and will be responsible for when new releases come out. Making sure you have a process to build that and maintain that build for your specific use cases is key. We'll jump into the configuration and go a little bit further with the individual components before Adnan gives you a demo. Configuration by default is in this Etsy OTel collector contrib. If you're using the contrib repo, config.yaml, but it's made up of a few components, and it matches very closely what we talked about. It has a receiver section where you define those receivers, processors, exporters, and extensions. And then you pull them all together into pipelines. So you're building pipelines based on the telemetry type. So if you're building a pipeline for traces, for metrics, and for logs, we'll jump into those individually and look at what each one looks like. So for receivers, we're configuring these, like I said, individually. So you're deciding what you want. If you need host metrics, there's a full OpenTelemetry registry with the link that we can provide after, where you can go in and find a receiver for your specific use case with examples of how to configure that. You can do that within Bindplane, which we'll show you later. But things like, host metrics log, syslog, those are all configured within the receiver section. This tells the collector how to gather that data, either endpoints to expose. In the example here with OTLP, where we're saying we're going to expose a gRPC endpoint at this IP address and port. Host metrics, you may define the collection interval, things like specifically which metrics you want to collect. For Nginx, similarly, you have an endpoint that you're collecting this from, or things like a generic HTTP endpoint that can be configured at a certain port. So this is some of these are going to be looking locally at a system. Some of them may make external calls to collect data. Some may just be an endpoint for you to send telemetry to. There's a wide range of types. Processors, again, there's some key use cases for these, but definitely the way to think about this is, what do I want to accomplish with my data? And usually it's in a few different, would fit into a few different buckets. Sometimes you just want efficiency, and that may mean batching the data. That can be more efficient for sending it to the next destination. So if you're sending it to a endpoint and you need to do this quickly, you may look at batching that data. Transformation buckets, this is where you may need to manipulate the structure of data to fit into a different format. That can all be done with processors. Filtering and reduction would be, we want to eliminate data, and this is the use case where you're thinking of there are fields, there's information that is not useful for my analysis later on. The more you can reduce that with processors and eliminate data that's not needed, the better. Usually ends up in reduced costs in a number of ways at the destination, but also in, there is a cost to sending what can be massive amounts of data from collector to collector. And the last bucket I think of is masking and redaction. So the processors for masking, for redacting data that you don't want. And this would be things like PII data that ultimately you don't want to leave either the endpoint or moving beyond a certain stage in your telemetry pipeline. A couple of recommendations here, and to call out production recommendations. The batch processor is generally recommended for production. It just lets you better compress your data, reduce the number of outgoing connections. And so even some of the default settings are usually a good place to start. But just think about this, make sure that you have this or have considered using a batch processor before rolling anything out to production. to increase efficiency. Some others to consider will be memory limiter. So if you are using a collector on an endpoint, particularly if you're need to be really careful with impacting other workloads, you want to consider having some limits that are enforced, and a memory limiter is one of those that will prevent a situation where you're processing too much, you're taking more memory than anticipated. This will prevent that collector from using resources that you weren't expecting. And then another example, the resource detection processor. This can be great for adding in additional metadata from a system before you're then sending the data along. So you're collecting, metrics, logs, traces, but it can be really helpful to also have information about that system that you're operating on. Exporters are maybe the simplest of these. We're taking everything that we've created and then sending it to a specific endpoint. That could be another OTLP endpoint. We'll talk about how this would work. It could be things like an S3 bucket, Google Cloud, or SecOps. That could be a Splunk system as well. And then you put it all together with a pipeline, and the pipelines are defined in the configuration. I'm showing here that we have traces, metrics, logs. You can define pipelines for multiple, but oftentimes it's best to keep them separate by telemetry type. And this is where you're defining the specific receivers that you're going to use, the processing that's going to happen, and then when you're going to send that, where you'll send that. And you can have multiples at each stage. You can do that in order, but that's how you're developing that pipeline from end to end. Extensions sit outside of those pipelines, and they're an optional component, but they are things that are not necessarily part of that flow of data. So things like a health check extension. This is a health check for the collector itself. Profiling extensions can be used to profile the collector if you need to understand some underlying issue. Usually it's going to be used during development, but these are the types of things to look at. And again, these are all available in the registry within OpenTelemetry Contrib, and there's a lot of documentation around the extensions that are available. A couple of pieces and things to call out here that are likely to be extensions that you'll need to consider. There are authentication extensions, and these are needed if you have endpoints that require authentication. So OAuth, basic auth, that's then incorporated into things like receivers or exporters. There are storage extensions. These are used for caching and queuing data. So if you need to ensure resiliency and ensure that there is not data loss at a certain stage, you'll likely want to have either file storage, which is most common, or database storage that's used before sending to the destination. OpAmp, which we'll talk about in a bit. This is a newer edition, although I guess it's been out for a couple of years now in one form or another, but this is an extension that allows a collector to be remotely managed. And it's how we orchestrate and manage OpenTelemetry at scale with Bindplane. And we talked about some of the others, so I'll skip that piece for now. This is just a little bit more in it. Another tip for running this in production. You really want to consider data queuing, and this is, when you have a situation where data loss is a problem, and that is certainly something you need to consider. Some data, this may not be relevant, but if it's something you need to guarantee that you have consistency throughout, you'll want to queue data at each stage and understand the potential and the limitations of that. So as I mentioned, you use the storage extension. It's going to be a file or database. Typically, we recommend just local file. You're then configuring that queue size, and this is based on the system. So just like when you're thinking about memory usage, you do want to think about how large can this queue be? How critical is it at this stage? So a collector deployed on an endpoint that has a local workload that's a critical workload, you may want a queue that's very small. And then at a gateway collector that's designed specifically for processing and managing data, you may have a queue that's much larger. But those extensions, the file storage extension, will be added directly to your exporter. So configure it as an extension, in this case, file storage, define some of those, where that's going to locate, where that's located, the size of it, and then include that within your exporter. And the last concept we'll talk about is connectors, and this is another relatively new concept that's been added to OpenTelemetry, the collector. So we talked about pipelines that pull together receivers, processors, and exporters. We talked about how they're typically broken down into telemetry type. But the challenge that people ran into was, well, if you do that and you have a log pipeline, but what I really want to know is, I want to know how many logs are passing through over the past minute. That's when you would consider a connector. What it does is it takes a pipeline, say a log pipeline, and then can convert it through a certain action into a different type. So for the log example, the count example, maybe we look at traces, we look at logs, but we want a metric created to go into, to be sent off to, maybe an IT operations system that says, this is how many traces are coming through, this is how many logs are coming through of a certain type, and do I need to investigate that? And so that's a situation where you would want to use a connector to connect one stream to another, or one pipeline to another pipeline. Hand it over to go through this and show what it looks like in real life.
Awesome. Yeah, it was a really, really nice intro section here explaining everything that we basically need to know before jumping into the demo about the OpenTelemetry Primer, and also obviously talking about the collector and all of the intricacies there. So the demo itself, it's quite literally going to take all of the last 15 minutes or so that Mike was explaining, just giving you a nice little hands-on overview of how to first obviously install the OpenTelemetry Collector on a little Linux VM, but also then configure a receiver to use host metrics and file log to basically export syslog logs. And then, of course, set up OTLP over HTTP to send those logs and metrics over to Grafana Cloud. So this is a nice little setup that I like using. Specifically, what I'm essentially using, we can also just minimize this for a bit. Essentially, what I'm using is a little Linux VM. So if I jump over here to my terminal and my sandbox, if I just run uname A, it's going to give me a overview. So it's Debian, and I'm running 64-bit GNU Linux. So it's just a little Linux VM that I have set up for the demo here. What I really want to do is I want to first set up host metrics and syslog as a file log receiver, and I want to send that to Grafana Cloud. So let's say in this exercise, I have my Grafana Cloud running here, and I want to have all of my logs and metrics show up within my Grafana Cloud instance. Now, so what's specifically, what am I supposed to do? So that's the general question. Well, okay, so I want to install a collector. So I'll obviously jump over to the OpenTelemetry documentation, and I'll go check out the quick start for the collector, right? And here, the quick start is great if you want to use Docker, and then second, if you just want to make sure that you have some telemetry flowing through, making sure, essentially just validating that it works to see telemetry at all. But that doesn't really fit our use case per se right now. So I'll just jump over to the install a collector, and I'll try finding the Linux install, right? Yeah, so this is the one. I'm obviously running Debian, so I'm running a Debian Linux VM, and this is great. I have my AMD64, my snippet for installing the OpenTelemetry collector. But there is a kicker here. If you look at this specific name, it says OTel call 0.122.0, etc. This will install the core distribution. So Mike was just explaining the different distributions that are available of the collector. And if you install this, you're probably most likely not going to have all of the features in the collector baked in that you really want to have. So how do we work around this? Well, you can just manually jump over to the releases. So I've opened up that link here already. So this is the releases on GitHub for the collector. And if you scroll down a bit, you'll see right around here, we have actually the ARM, we want the AMD versions right here. OTel call -contrib, that's the one we want. Linux AMD 64. So the kicker here is I've already prepared a little snippet, so we don't really have to do any writing. But if I jump back into my sandbox and I paste in the snippet I have, if you check this section, it says OTel call -contrib. And that's the kicker. So now if I go ahead and install this, this is going to run the install and get me the Linux Debian installation for the OpenTelemetry Collector contrib. Awesome. So if I just do a ls, I'll see that, yep, I have my OTel call contrib package here and it's installed. I can also just run a status for my systemd. So it's obviously installed as a systemd process. I can do a systemctl status and I can see that, yep, I have my collector running, but I have the correct version of the contrib collector running. So now the next step here is usually what I like doing is I want to make sure that I have logs or internal logs of the collector showing. So if I can do a journal.ctl and I can check the standard output of the collector, and I can see here that, yep, I'm getting proper internal telemetry from the collector getting output to the standard output. Now, once you do install the collector, by default, it will show you, actually, it will generate a default config file. So under etc OTel call contrib, so this is the directory that Mike was just mentioning for the config for the collector, you have two files. So the first one is the config YAML, but you also get this OTel call contrib conf. So now if I just do a cat for the OTel call, this is just a startup config. So this basically just says to the process itself, make sure to use the config YAML that's in this directory. So it's nothing special. But in case you want to use a different file, or if you have multiple files and you want to load different files for different use cases, then you can just change this. But yeah, let's move back to the config YAML here and just open that up and see what it looks like. Now, this particular file obviously has the extensions. It has receivers, so OTLP, OpenSenses, Prometheus, Jaeger. Same thing that Mike was just explaining. Has a processors section and exporters as well. The only exporter that we have here is the debug one. So that's the throw everything to standard output. So that was what we just saw in the journal.ctl. And then obviously the pipeline with the traces, metrics, and logs. And we're getting all of the receivers we're using. We're putting in all of the receivers for the logs, metrics, and traces. And then obviously the debug exporter here. Cool. Now, to have a little nicer look at this, and then obviously going in and adding the host metrics and the syslog, actually the file log receivers, let me go in and open up this one. So I've just started an SSH connection to this same sandbox, but using VS Code, just so we can have a little nicer overview. And I'll zoom in a tiny bit more so we see what's happening. So to add in our own receivers, I've just gone ahead and added created a little snippet so we don't have to do any writing. So I'll just paste it in here so we can look at it like so. And let me walk you through what's happening here. So right now we have the receivers and we have our host metrics and we have our file log. The file log is looking at the var log syslog. That's cool. But we're also adding a custom attribute just so we can make sure that when we look at the logs, we know that they're actually coming from syslog. We're keeping the same processor, we're keeping the same exporter, and we're just replacing the receivers here to use host metrics and file log. So this is just a little small config. One kicker though, if you want to look at syslog logs, the OTel collector doesn't by default have permissions to read those files. So what I tend to I like to do is I want to make sure that the OTel call user is actually added to the admin group. So I'll just run the user mod. I'll go ahead and restart the collector after that. And once that is done, if we give it a second, and if we do a status of the OTel call contrib, we should see that, yep, it's running fine. And if we look at the journal CTL, we'll see that we're going to get, yeah, there we go. So if we scroll up here, we see right here, we have the log, source, syslog. So the initial part of setting up the receivers is a success. So we can look at both the host metrics and the syslog logs in our standard output. And now we just need to add the exporter to send everything to Grafana. Luckily enough, again, to speed up the demo, I've created another little snippet so we don't have to do any typing. And if I go in and say, let's paste this in here and I'll save it up. And let's walk you through what's happening here. So now we're using the basic auth extension that Mike was just mentioning, the extensions a second ago. And I'm using my credentials for Grafana Cloud. I'm keeping the same receivers, but I'm adding a resource processor. So this is going to give me a nice little a label inside of Grafana Cloud that's going to tell me, yep, if I want to search for my logs under the service name syslog, it's going to make it super easy to find those logs. And then obviously I'm adding a OTLP HTTP exporter with the basic auth authenticator. And I'm replacing my debug for the OTLP HTTP exporters right here. And obviously don't forget to add the extension here as well. And once you go ahead and restart the collector once again, and go ahead and do another journal CTL, this is going to stop pushing logs to my standard out because we removed the debug exporter, but it's going to start sending to Grafana. So now if I do a jump back here to Grafana and give this a second to refresh, there we go. So now I have a syslog service name basically as a label, and all of the logs that we were getting in the standard out is now getting pushed to my Grafana logs. And same thing for the metrics. If we do jump in here, we will eventually see some metrics coming in here. But yeah, we're a bit out of time for the demo, so we'll jump back into the slide deck in a moment here instead. Cool. We can always come back to this part in a bit.
Perfect. Thanks. And we'll show how you can see how you can do this in Bindplane as well to do that in a low code way where it kind of walks you through those different steps. But that's all the core components of how do we get a collector deployed. Look out for those edge cases that we're talking about, debug that pipeline, and then you have a template that you can use throughout your environment. And then when you get to a point of deploying, this is what I want to talk about next is there are a few patterns that you consider, and especially when you're talking about high scale environments, there are a few recommendations to patterns. And so I'll walk through a couple of those, starting with the simplest. And this is really matches what we just showed, which is we have a host, we have an application or source running. You may have the SDK instrumenting an application. That collector running in what we would call agent mode can then gather, process, and send data wherever you want it to go. So this is a great way to get started, and it's very clearly mapping. We have a collector gathering telemetry, it's sending to this specific destination. But the problem with this is that it's not a very scalable solution when you're dealing with many sources, many hosts, containers, and it can be inflexible. So if you need to change where that data is routed, you have to change that in every single collector that you've deployed. So jump to the next slide. We really recommend, and the community recommends, that when you're deploying this at scale, you consider a gateway pattern where you have OpenTelemetry collectors deployed at the edge, very close to the host or on the host. And then you have a gateway collector. This is the same binary, it's just configured for a different purpose. And the agent mode of the collector, this is designed to offload your trace metric log telemetry, gathers any local metrics or logs, does any pre-processing or caching that you need it to do. Typically, you'll limit the processing at the agent stage, and then it's sent via OTLP to the collector operating as a gateway. And at the gateway, you do things like processing, any of the heavier processing that you may need to do. You handle all of your routing. If there's any compliance, masking, filtering, you'd be doing that typically at the gateway stage. And the flexibility here, you have a local agent able to collect all the metrics logs that you need from a node or a host or container. And then you have a gateway for a dedicated purpose. It's good for separating concerns. The cons are it increases the complexity by an additional agent, but it really makes it much easier to route data easily. So when you decide, I want to try this new feature of a new product, just changing it at the gateway level and not at all of your agents. The next stage in this, when you really get to, and the OTel collector by itself is very performant. But when you get to a certain scale, you're going to need to scale that out, and that would become a bottleneck with throughput. So when you're getting to that point where you have, you're dealing with large amounts of telemetry going to a gateway, then you want to go to a load balanced auto scaling collector. And this is going to follow standard auto scaling patterns. We recommend that you just use what's available to you. So if you're using cloud, use a cloud auto scalers, either containers or the virtual machines. There is and this can be a confusing point sometimes, there are load balancing options within the collector. Typically for this purpose, you just want to use a standard load balancer, and collectors configured for that. But this is highly scalable, allows you to increase processing that you're doing, any normalization, and still maintain the capability to route data. And this is the core of a telemetry plane. So this is a recommended architecture. It's highly scalable. You're not just going to have one collector or a gateway or a collector gateway group. You'll have many, but other than that, this represents what it's going to look like in an ideal end state. We show one gateway here. Some customers, depending on the size of an environment, may have multiple stages. They may have one gateway for a certain region, and then it sends to another region where the majority of their telemetry is ingested. That can be telemetry can be routed based on application or workload type. It's one way that a lot of teams handle it, or it can be managed by telemetry type. So have log streams, trace streams, and then metric streams all separate. And that ends up being a business decision, what the architecture that makes most sense for you is going to look like. The last piece, we jump into to talk about Bindplane a little bit, is the Open Agent Management Protocol. This was added to the OpenTelemetry project a couple of years ago, and it came out of a number of teams. Bindplane was one of them that have developed remote management of agents in a proprietary way. Everyone had done it their own way. We know that it's a necessary component when the scale of your environment gets to a certain size. So we came together and developed an open source network protocol to remotely manage these and handle that at very high scale. So when you get to a point where you're deploying thousands or tens of thousands or hundreds of thousands of collectors throughout an environment, OpAmp is designed to manage those, report on the agents' telemetry, so the health of the agents, do things like credential management, reporting on status, agent upgrades, so automatically rolling out upgrades to those agents within a secure auto update capability. And really, this is a key piece to managing this at scale and understanding and being able to control configuration. And what you find typically as you're scaling out a telemetry pipeline, some of the the more general DevOps tooling for that can be challenging to get that to work at scale. And so jump to the next slide. That's really a big focus of Bindplane. And Bindplane's an OpenTelemetry native telemetry pipeline. We built it to manage your SIM and observability costs at scale, allow you to manage a very large enterprise environment, and manage the telemetry pipeline through that. And customers dealing with petabytes of data per day, pushing that from every source you can imagine through this pipeline, and all managed through this orchestration layer of Bindplane. So we focus on routing data, standardizing the data, and really reducing the data as it moves through the pipeline at each stage. This is just a basic architecture diagram. And Bindplane, we have a SaaS version, we have a self-hosted version you can deploy internally. And that just depends on, SaaS is going to be really easy to get up and running. You don't have to install anything. It's easy to deploy collectors and you're ready to go. But to get a sense of the specific details of what you need access to, we have the Bindplane instance. It's where your browser and your API, CLI are connecting to. We also connect to our GitHub repository for the latest Bindplane collector updates. And then we have your network, so the customer network with OpenTelemetry collectors, Bindplane collectors, which is just our distribution of OpenTelemetry. And this can be exposed or it can be deployed throughout your environment, throughout your network, or even multiple networks or data centers. And then ultimately that telemetry is flowing from your gateways to that destination, your observability vendor, your security vendor, your cold storage. It can send it to any of those destinations. So that's the architecture, but now I think we're going to jump into actually looking at Bindplane and walking through some of the things we did before and going a bit further.
Yeah, exactly. So, as Mike mentioned, quite literally everything we were explaining in the last few minutes, how Bindplane works and how OpAmp works and how it all intertwines into a telemetry pipeline. Yeah, let's just go ahead and show it. So we'll first start with a new Bindplane Cloud instance. We'll install the Bindplane distro for OpenTelemetry Collector. We'll use it as a gateway on the same Linux VM that I was showing a moment ago. And then we'll also create a pipeline to forward telemetry from an OpenTelemetry demo instance running in Docker to our Grafana cloud that I was showing a moment ago as well. So let me go ahead and just close this one up. And I think for the get-go, the best way to get started is actually to jump into the OpenTelemetry demo architecture first, just to make sure we all know what it is, how it works, and all of the components within the OpenTelemetry demo. So the OpenTelemetry demo, long story short, it's the official demo repository of the OpenTelemetry community that showcases what OpenTelemetry can do. It's also a learning repository where if you don't know a lot about OpenTelemetry and you want to learn how to instrument your code, if you want to learn how to use the collector, basically anything, it's contained within that repository. It has dozens of different services. It's a microservice architecture. It's using almost, I think it's 11 languages for now, using instrumentation across all of the languages. And it's also using a telemetry data flow with the collector. So it has a setup telemetry data flow using the OpenTelemetry Collector in agent mode. So remember what Mike was just explaining. The agent mode collector is deployed within this Docker Compose setup with all of these other services, as well as Prometheus, Jaeger, and an internal Grafana instance as well. So this is all self-contained in this Docker network. What we want to do now with this demo is specifically add a Bindplane instance, or basically a Bindplane collector, to behave as a gateway. So on the host network of our VM, we want to use the Bindplane collector to get telemetry from from our OTel demo Docker setup, and then flow that through the Bindplane collector and then into Grafana Cloud. Now, let me jump into the VM, so the little sandbox we have, and let me go in and just show you. We have this OpenTelemetry demo folder. What this basically means is that it's just cloned from the OpenTelemetry demo repository. And I've just started it with a Docker Compose. So just to show you, if I do a Docker Compose PS, it's going to list out all of the services, all of these. You can see FlagD, Grafana, you can see front-end accounting. So all of the services that you can see here are now running within this Docker Compose setup. And then obviously to show you a bit nicer overview, once again, I have my VS Code here SSH'd into the sandbox. And if I open up the Docker Compose YAML, I can see here as well all of the services that are running from the OTel demo. So you can see accounting, ad, etc., etc. Now, what do we want to do first? First, we want to jump into Bindplane, and creating a new instance is just as simple as landing at the login page. Go ahead and sign in. So this is going to create an org for you. This is going to create a project, and it's going to basically run a Bindplane server instance for you to start using right away. Step 2 is going to the agents, and here going to the install. So you remember in a half hour ago how complicated it was for me to figure out which version of the collector, whether it was the contrib or whatever. So it's quite a mental geometry game of juggling to figure out what I actually need. For Bindplane, it's not so much. You just say Linux, I want the stable version of the distro. I get a one line install command that I copy and then put into my instance right here. It's going to fetch the package, it's going to install it, it's going to basically do everything with that one line of code, that one install command. And hey presto, that's it. It's complete. It's all done. Jumping back here, it's going to take a second for Bindplane to register this new agent. If we do a quick reload, let's see if it's registering or not. Oops. Well, the demo gods are not always with you, but lucky for me is that I always have a backup. So let's just switch over to the other instance where I have everything running already. We can do that by it's going in. There we could do this one. So same thing. We have the OTel demo. We have a collector, a Bindplane collector running already. And then we can do that by jumping in here to this particular screen right here. Next step, once you have an agent running, you want to create a configuration. So I'm going to go in and say, just want to detach these. I want to go in and say, create a configuration. So I'm going to jump in here and say, yeah, what do I want to do? So I essentially want to get OTLP as a receiver. So I want my Bindplane collector to get all of the telemetry from my OTel demo, and then I want to send that to Grafana. So I want to do OTLP to Grafana. That makes sense. I want to make sure it's Linux, and I want to go ahead and hit next. So my source is going to be OTLP, and it's all going to stay default. So it's running on the default localhost of the server. I have my default gRPC and HTTP port, and that's basically it. I can add more sources. I don't really need to, so I can go ahead and add a destination. And before I add the Grafana destination, I want to do some testing first. So you remember I was using the debug exporter in the last demo. I'm basically using the same. So we have something called dev null that basically lets you start up a pipeline like this, but it's not really sending anywhere. So this is just for me to make sure that my processors are set up correctly, just to make sure that I have everything in my pipeline configured as I want it. I will also just do a quick upgrade to V2 because We recently released the V2 layouts for the pipelines, and they are just freaking beautiful. So I'm going to go ahead and use them because I just like them a bit more. And yeah, and now once I'm done with the config part, I'll connect an agent. So I'll go ahead and connect this agent. And I can go ahead and start a rollout. So now once this is rolling out, so this is the op amp in action that Mike was just explaining. Bindplane is communicating to my collector via op amp, and it's telling it's basically pushing down the config, it's configuring it, and it's telling it to restart with that new config. So now what's the kicker? We need to go back into our Docker Compose. So if we jump back into, I'll just need to grab the correct terminal window, and basically think it's this one. There we go. Right, so we need to go into the Docker Compose, and we need to look at the OTel collector service specifically. To be able to get the telemetry out of the Docker network into our host network of the Linux VM, we need to add this little host Docker internal. Why? Because in the OTel call config, there are specifically two. So there's a basic one that I don't want to touch. So this is all of the internals of the OTel demo and all of the telemetry that's flowing internally. I want to add an extras file, and I want to add my exporter right here. So I'm sending everything to an OTLP exporter using the Docker host internal, or host docker.internal, and I'm setting it across all three pipelines. I'm adding new pipelines, and I'm setting the OTLP to OTLP bindplane gateway exporter. So this is basically keeping all of the existing telemetry setup, the telemetry flow from the OTel demo. I'm keeping that intact because I want to keep that packaged in. But I'm adding this external factor where I'm sending the telemetry outwards from the network to my Bindplane collector that's running in gateway mode. So now if I did the demo correctly, I'm going to do a fingers crossed moment here. I'm going to jump back over to the Bindplane UI. And yeah, I can see that I'm getting a 1.2 megabyte per minute throughput. Awesome. So I'm getting data flowing through. And if I open up the processor, I'll see exactly a snapshot of the exact data that's flowing through my collector. What's cool here is that it's going to dev null. So I'm not sending anything to Grafana yet. So I can do any transformations, processing, filtering, basically anything I want. I can do visually and get a direct overview of what's happening before sending anything to Grafana, which is if you have massive amounts of data flowing through, you don't really want to send all of it to Grafana and spend a bunch of money just trying to figure out whether the processing is right. So I tend to do it this way. You leave it to dev null. You go ahead and say, oh, I want to add my delete empty values processor. I want to go ahead and add, let's say I want to do some more complex filtering. Maybe I want to do some, I don't know. We can do let's see what we can do. Yeah, we can also do I think a deduplication might be dedupe. We can do a deduplication as well. We can add that. We can add of course, we want to add a batch processor, not to forget that one. Mike was just mentioning how batch processors are important for, and also production, recommended for production. We can do something like 200, not to keep it too crazy for a demo. And also one more thing that I think is very useful is if we do the filter by severity. If I do, let's say, warning, you're going to see, actually, yeah, let's do like that. You're going to see that everything is on the left-hand side that's labeled information or info is going to get filtered out. But if I change it, let's say I want to do bring back info, and I save it, it's going to keep the info logs on the left-hand side, and it's going to show them on the right-hand side as well. So this is a very, very convenient and very nice a nice way of adding processors visually. And it's, I mean, to be honest, it's just so much easier with with the plane collector, you just have to check the debug. You have to figure out whether it's coming or not, whether if you change anything, and it's quite tedious, quite a tedious process. This makes it just so much easier to do. And then obviously to roll out this change, to deploy this change, you just click a button, and this is going to be pushed out down to your collector that's running in our VM. Now, how do we validate this is actually going to Grafana? Well, we need to add another destination. So we're going to go ahead and click the little plus here, and we're going to do a Grafana. We're going to do Grafana Cloud. And for this particular setup for Grafana, it's the same as the basic auth extension that I showed in the previous demo. You put in your endpoint, your Grafana Cloud ID, and your token. I've luckily already done this before the demo, so we don't have to add in all of those things right now. And with that, we have the Grafana Cloud destination added. Now to connect it, you click the little plus, you go ahead and point it over there, and you can go ahead and delete or disconnect the connection with DevNull. And then you can obviously go ahead and do that for the metrics as well. And finally, you can also do this for the traces as well. There we go. Now we are ready to roll out this final change. Now, if we give it a second or two, and we go back to our logs, let's do last 5 minutes, and let's just do a little reload. And there we go. So now with this, we have the front-end proxy recommendation card. So all of the services from our OpenTelemetry demo, we're getting logs into our Grafana Cloud instance. If we check the metrics, give them at least a couple of minutes, we're going to see metrics start flowing. Yeah, we have the container block. So all of the metrics are already coming into our Grafana Cloud instance as well. And with that, I think we are out of time. So we're going to have to pop back into our right here and just open up the slideshow, and then we can probably do some questions.
Hey, Adnan, a couple quick questions. We had quite a few I was able to answer in real time, but some of the more recent ones. One about the batch processor and just why you chose 200 as the batch size.
Oh, that's just for the demo because I wanted to actually get the batch going into Grafana. If I chose a wildly large number, then it would probably take a moment for it to batch all of the logs and or all of the telemetry and get it in. So for production, I would say, well, Mike, do you have a rough idea of what we should keep?
It's a tough one because it really depends a lot on where the data is going, and then you're really looking to optimize for the destination typically. And so there's going to be, based on where you're sending that data, there's usually going to be roughly an optimized level to patch it. But it's tough to say that in a general way without knowing where you're sending. So usually when you see a batch, it's like before you would export somewhere. But we might, I'll take a look and see if we have recommendations that we could send along just to give people a little bit more guidance on it. Otherwise, it's typically tied to the exporter that you're using. And with some of these, in Bindplane, we actually will embed a batch processor with the exporter. So you don't even see it, it's just automatically applied. You know, and shown in documentation that this is what we're doing before we send it to the next location.
Yeah, that's just another level of convenience that, you know, I like making sure smarter people than me do something, you know, right away automatically. I just wanted to kind of help, if that makes sense. But yeah.
Sweet. Thanks, guys. One other question, which I can take a stab at. So the question is, if we have many hosts in the organization level, how can we roll out to all hosts? It's a great question. So if you're in Bindplane, there's kind of a couple of pieces of hierarchy you'll notice. So when you first sign up, you'll be asked to create an organization. Now this should roughly map to your company. So you can kind of think of it as the highest level. And then when you're within that organization, you can create many projects, and these projects are isolated user access controls, are different between them. And so folks tend to use projects to represent teams within the organization. So you might have an operations team, security team, et cetera, and they would have different projects. And then for actually rolling out your changes to many different hosts, a configuration acts as kind of that grouping mechanism. So you would build a configuration like Adnan was showing with that OTLP to Grafana, and then you can assign that configuration to many hosts. Now, in this case, we had just assigned it to that one gateway collector. But you could imagine maybe you've got, yeah, Adnan's pointing it out, we've got one configuration that has 8,000 workstations that it's being deployed to. And so when you make a change to this configuration and you roll out that change, it will deploy to all those collectors. The rollout process will also do it in phases, so it's safe. We'll test one first, validate that it actually worked, and we've got additional rollout types that Adnan's showing off. So you could label your agents, dev, stage, prod, and then roll out to specific groups.
That's a great question, and I think the answer was on point. And yeah, I think we are out of time. We're actually a minute over. Yeah, I'm thrilled for everybody that joined. Super happy that I think, obviously, hope that we found it educational to some point. And thanks for you guys, Mike and Ryan, did a great job as always.
Yeah, I appreciate everybody for joining and sticking with us through all of it. It's a lot of material to cover, but thanks everyone. Have a great rest of your day.
Thanks, everyone. We'll talk to you soon.
Thank you. Bye-bye.